Okay, we're going to start talking through 8.3, which is transition matrices and long-term trends. So we've already looked a little bit at transition matrices, which talks about the movement from one situation or one location to another, from perhaps in different time periods, I guess you could say. So from one week that people are here, the next week they'll be here. So in our transition matrix, remember we talk about decimals because we want those columns to sum to 1 because 100% of those people are going to end up somewhere or they're going to have been somewhere. So T is our regular transition matrix. All right. And T squared has no zeros. So regular transition matrix is a transition matrix that has either no zeros itself or one of its powers has no zeros. All right. We don't use this a lot in the work that we're doing, but it's just something to be aware of. Keep it in your head, the definition of it. And you want to check to see if your matrix is a regular transition matrix using these criteria. So the equilibrium state matrix. So although transition matrices have constant change, for a regular transition matrix in the long term, the state matrix actually gets to a point where it stops changing from one transition to the next. So it will actually get to a point where you hit that sort of equilibrium and the values stay the same for where people or objects sit. So it's called the equilibrium state matrix or the steady state matrix. So two names that you need to remember and what that actually means. The transition continues, changes continue to occur, but they hit a point where they're actually sort of cancelling themselves out. So it stays the same as the previous one. So to find that equilibrium state matrix, we have to get to two consecutive high powers, and they stay the same. So for example, we might raise our transition matrix to 39 and multiply it by our initial state, get the value. And then we might raise that transition matrix to the power of 40, multiply it by our initial state, and we will end up with almost identical values, which means that we have hit an equilibrium state or a steady state matrix. So you can see here we were looking for after 39 iterations. So we raised our transition to the power of 39, multiplied it by initial state, which we've done here, and we get these values. Now remember, it may be appropriate to round if you are talking about things like people or birds or any kind of whole value. So if you leave it in a decimal format, you are not giving the most appropriate answer. So make sure that you're rounding appropriately where it needs to be. So then here, to jump ahead a little bit, we were looking for after 40 iterations. So we raised our transition matrix to the value of 40, multiplied it by our initial state, which we're doing through here. And can you see that we've ended up with two matrices that are the same? So our equilibrium state matrix is actually the value that we get. It's not when it occurred. When we're looking for the actual equilibrium state matrix, it is the solution that we get. So at what point we hit it in our values. So just to go back, a regular transition matrix T is a transition matrix that either has no zeros itself or one of its powers has no zeros. So for a large value of n, so t to the power of n, it stops changing and has equal elements in each row. The state matrix Sn stops changing and becomes the equilibrium state matrix. Both t to the power of n and Sn give information about long-term trends. All right, and that's how to find the equilibrium state. So we're going through here. So we've got a fleet of trucks. They start at two depots. So this day and the next day. So this day on the top, next day on the right-hand side. By the end of the day, they might end up at another depot. So this shows us the split. So if they started at this day, 95%, so remember we're putting it into a decimal format inside our matrix, we'll end up at depot A the next day. But that 0.05 who started at A will actually end up at B. It tells us how many trucks started at each depot, so that is how we're going to create our initial matrix. Okay, so T has no zero elements, so there will be an equilibrium state matrix. All right, we're going to find it. So it's not about the when. It actually doesn't matter how many iterations you are choosing to do. It just wants to know what that matrix looks like as a solution. So what values you're getting in there when it hits that equilibrium state. So we've got our S of O, so that's our initial state matrix. Which we took from the question. We've already been given our transition state. Now, you can choose any number of iterations, so as long as they are consecutive and high value. So 39 and 40 can be quite good. You might choose to go higher, you might choose to go lower. But remember, if you're not hitting an equilibrium state when you are trying it, perhaps you do need to go higher. It might be a good idea, though, to start at 39 and 40. If you're not hitting equilibrium state, try 2 consecutive numbers that are higher and see if you can find that equilibrium state. So can you see here we've got that these values are approximately 105 and 35. That means that they have done rounding. Now, you're not going to have half a truck at A and half a truck at B. All of your trucks have to be at either A or B in terms of like the whole truck has to be there. You can't just leave a wheel behind. So remember to round where appropriate. Are you talking in terms of something that is a whole value, which you generally will be for transition matrices? And make sure that you use it is approximately, because it is not exactly 105 when you solved this, okay? So be careful with some of your notation that you are using. So we did our transition matrix to the power of 39 multiplied by our initial state, and we got approximately 105 and 35 trucks at A and B. Then we did the same thing but raised it to the power of 40. Remember, they have to be consecutive numbers. You can't use 39 and 45. You would have to use 39 and 40 or 44 and 45, consecutive numbers. The matrices came out the same, which means we are at an equilibrium state, and that is the value of the equilibrium state. So in the long term, what that means is 105 trucks will be at depot A in the long term, and 35 trucks will be at depot B in the long term. So what percentage of trucks are at depot B in the long term? So how many trucks do we have in total? Was 140 trucks in total. 35 of our trucks in the long term end up at depot B. So 35 out of our 140 trucks are at depot B. We're going to multiply that by 100 to turn it into a percentage. So 25%. So 25%, make sure you show you're working as well. Do not just write the answer. Show me you're working so I know you know what you're doing. 25% of our trucks will be at depot B in the long term. Okay, long-term trends. We can find long-term trends from a transition matrix alone, even if we have no initial state matrix. So we can find the equilibrium state matrix by creating any state matrix whose elements add up to the total. So for example here, we know that we've got a school running weekly coping with year 12 program throughout the year, and it's got 3 electives: study skills, managing stress, and organizational skills. Each week, the students choose one of the electives. All right. And we've got our transition matrix here. So this week, next week, so that movement, remember, our columns are summing to 1. So we've got this here. So let's have a look. What percent? So show that there will be an equilibrium state. What percentage of students are expected to select managing stress each week in the long term? If there are 270 year 12s and the students find the equilibrium state, and hence how many students are expected to select study skills in the long term. Cool. All right, and we've got the rest of the questions there. We won't spend too long reading them. So t to the power of 2. So because we've got a 0 element, we need to raise it to the power of 2 to make sure that we have got no 0 elements. So we're checking that t to the power of 2 has no 0 elements, so we're going to find an equilibrium state. So we're doing that test first. So we're going to raise t to the power of n for 2 large consecutive values. So again, they've picked 39 and 40. You might choose to go higher. It is up to you. So when we do that, can you see that our values in that transition matrix, once we've raised it to the 2 consecutive powers, are almost identical, okay, if not identical. So what that means is, so when we come down here, we're going to convert the required decimal to around a percentage. So we're looking at managing stress in the long term. Okay, what percentage of students are expected to select managing stress in the long term? So they're saying it's that 0.1579. So where does that value come from? That is the same value that runs across here. Okay, they are all the same. So we take that value, multiply it by 100, take it back to its decimal format, which is 16%. So we're not adding that row or anything like that. Can you see that each value in the column is the same across that row? So 16% in the long term are going to select managing stress. We're going to create initial state. So all that means is we know that there are 270 students. As long as the elements add up to 270, you can place them in any starting position. It hasn't given it to us, so you are free to choose. We are then going to find what that steady state matrix looks like. So from our created one, because we know that we are getting to a steady state at some point. So it doesn't actually matter how many started in which position, they're all going to end up in this steady state format. So test it with a different initial state and you'll see that you actually end up with the same result. So we're raising t to the power of 39 times our initial state, t to the power of 40 times our initial state. The initial state that we created, as long as it sums to the same number, say the correct total, that's all that matters. So when we do that, we end up with our steady state or equilibrium state. So in the long term, we are going to end up with 128 students selecting study skills, 43 and 99 for the different categories. So then we can read straight from that matrix that in the long term, 128 students will select study skills.